Assalamualaikum and hi everyone. So today we look at our new subtopic from chapter 3, resistor in series and parallel. So the first thing we are going to look at are at the characteristic of resistor in series and parallel. So now we are going to apply whatever we have studied about resistor in series to solve the question on resistor in series. So we know that for resistor in series, the characteristic are the current that flows across the circuit is the same current. Total current is equals to current across each of the resistance, whereas the voltage is the total voltage is equals to voltage across resistor 1 plus voltage across resistor 2 plus voltage across resistor 3. And whereas for the resistance, the R total here is R1 plus R2 plus R3, where you have to sum all the resistor that is involved in the calculation. So the question that we have here is we have a power supply of 10 volt, where in the circuit there is 3 resistor connected in series. Given that the value of R1 2 ohm, R2 4 ohm and R3 5 ohm, the question asks to find the voltage across R1, R2 and R3. So basically we are going to look for voltage across each of the resistance V1, V2 and also V3 here. So we know according to the Ohm's law, voltage is equals to current multiplied with resistance. So to find V across resistance 1, so our V1 will become V1 is equals to I1 R1. And since we know that current that flows in a series circuit is the same current for each of the resistance, so the current that leaves the power supply here is the same currents that enter each of the resistance. So my V1 is equals to I1 R1 becomes V1 is equals to I R1 because it is the same current. So my voltage across resistor 2 becomes I R2 and voltage across resistor 3 becomes I R3. Since I know the value of all the resistor here, R1, R2 and R3, I need to first deduce the total current that is flowing in the circuit before I can find the voltage in each resistor. So what I'm going to do is I'm going to use the V total is equals to I total R total to find my I total, which is the current that flows from the power supply. So I know my V total, my R total can be found using the equation for resistor in series, where R total is equals to R1 plus R2 plus R3. So I will end up with R1 2 ohm plus with 4 ohm plus with 5 ohm, I'll get a total of 11 ohm as my R total. So now I can find my I total, where my I total is 10 divided by 11, which gives me my I total such as 0.91 ampere. So this is the current that flows from the power supply, and that is the same current that is going to pass through each of the resistance. So now I can find my V1 such as 0.91 multiplied with R1, which is 2 ohm. I'll get my V1 as 1.82 volt. And my V2 now becomes 0.91 multiplied with resistor 2, which is 4 ohm. I'll get 3.64 volt. And the same thing for my V3, which is I 0.91 multiplied with R3 5, I'll get 4.55 volt. So these are my voltage across each of the resistance. Next, we are going to look at the resistor in parallel. So we have resistor, 3 resistor R1, R2 and R3 are parallel to each other. So we know when the resistors are parallel to each other, the equation of the characteristics becomes 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3, whereas the voltage from the power supply is equals to voltage across each of the resistor, and the currents that flows from the power supply will be split into all those three resistors, which leads to I total is equals to I1 plus I2 plus I3. So as you can see here in the circuit here, the voltage given from the power supply is 10 volt. Therefore, the voltage across resistor 3, which is V3, is also 10 volt. Resistor 2, V2 is also 10 volt, and also resistor 1, V1 is also 10 volt because they are parallel to each other. And for current, the current that leaves the power supply is going to meet a junction here and is going to split. So as we can see, the current is going to split as it meets the junction. So we are going to sum the currents across each of the resistance to get the total current. However, the question asks to find current across R1, R2 and R3. So we want to know the current across R1, R2 and R3. So what I'm going to do here is I'm going to use my Ohm's law. V is equals to IR. This is the magical equation in chapter resistor in series and parallel. It is very helpful. So as you can see, if I want to find the current across R1, so I'm going to simplify this equation such that V1 is equals to I1 R1, where the Ohm's law now is focused across the resistor 1 only. So as you can see, V1, which is the voltage across resistor 1, is equals to the V from the supply, which is the 10 volt. So my equation becomes V equals to I1 R1. So I know the value of V and I know the value of R1. So I can simplify my I1, which is V over R1, where my V is 10 volt divided by R1, which is 2 ohm. So I'll get 5 ampere as my current that passes through resistor 1. So I'm going to use the same equation for my resistor 2 to find the current across resistor 2. So V2 is equals to I2 R2. So my V2 becomes V is equals to I2 R2. So now I2 is actually V over R2, where V is 10 divided by R2 is 4 ohm. So I'll get my I as 2.5 ampere. So this is the amount of current that is passing through the resistor 2. And then for my resistor 3, the current across resistor 3, I'm going to use the same equation. V3 is equals to I3 R3. So it becomes V is equals to I3 R3. So where my I3 is equals to V over R3, where V is 10 over R, 5 ohm. So we'll end up with my I3 as 2 ampere, which is the current that passes through the resistor 3. So that's it for resistor in series and parallel. What you have to do is you have to just remember the characteristic for each types of resistor, the parallel and the series characteristic. If you know that one and you use your Ohm's law, you can solve the question for resistor in series and parallel.